Hello, everyone, and welcome to Building SaaS on AWS. My name is Gunnar Grosch. I'm a developer advocate here at AWS. And this show is for you that are building or planning to build a SaaS product. We have this show every other week where I bring on SaaS experts to talk about specific SaaS related topics so you can learn more about building SaaS on AWS. And we want it to be interactive. So if you have questions, if you have comments, just pop them in the chat and we'll do our best to try to answer those. And this week, I'm happy to be joined by Farooq, Ashraf, and Ranjith Raman, colleagues from AWS. Welcome to the show, fellas.
Thanks, Gunnar.
Thanks, Gunnar.
So the regular viewer might recognize Ranjith from an earlier episode of the show. So let's start with you, Ranjith. Tell people a bit about yourself.
Yeah, sure. So first of all, thanks for having us. It's good to be back. So my name is Ranjith Raman. I'm a senior solutions architect with the AWS SaaS Factory team. So SaaS Factory, what we do is we work with organizations that are moving to a SaaS model and building SaaS applications. So we go out and we provide help with design and recommendations and just best practices around building a good SaaS solution. So that's what we do at SaaS Factory. And yeah, like I said, I'm happy to be here and looking forward to this conversation.
Great to have you back, Ranjith. And Farooq, first timer, welcome to the show.
Thanks, Gunnar. So yeah, my name is Farooq Ashraf, and I'm also a senior solutions architect. Somewhat different. I work with large ISVs based in the west coast of the United States, and I also collaborate sometimes with the SaaS Factory team as part of what we call as technical field communities. So I work with team members like Ranjith and others in helping our customers who are looking to re-architect into the SaaS model.
Great to have you both here. And the topic of this week is SaaS Identity and Routing using Istio Service Mesh and Amazon EKS. That's a mouthful. But Ranjith, to start with you, Amazon EKS, that's a topic we talked about last time you were here, and the EKS SaaS reference architecture. So how does this solution we're going to talk about today relate to that reference architecture?
Yeah, so I'll start talking about the EKS SaaS reference solution, and you're right, it was one of the first shows in your series last year, and so the solution itself, it's an end-to-end example of a multi-tenant SaaS application built on top of the Amazon Kubernetes servers, the Elastic Kubernetes servers, or Amazon EKS. And if you're building a SaaS solution, or if you're thinking about a SaaS application, there are a few things. There are several things that are important, but a few things that stands out is this whole notion of an identity and onboarding, which is very essential to any SaaS solution that you're building, and also sort of identifying what kind of tenants you have, right? So your tenants could be in different tiers. You could have tenants in the free tier, and then basic or like a premium tier tenants as well. And what you have to do is you have to think about, okay, how do I allocate resources? Like, do I share resources for a good portion of my tenants? Do I create silo resources for some of my tenants? So in the EKS SaaS reference solution, we took an approach where we used a namespace for tenant model. So namespace is a Kubernetes namespace that lets you have this boundary, like a virtual cluster for every single tenant, and then you could deploy their microservices into that namespace, right? So that's the backend microservices aspect. But we're not going to focus on that aspect today. We are going a further sort of upstream, like the whole identity layer, right? And what we did with the EKS SaaS solution was we used Amazon Cognito as our identity service that we use to onboard tenants and store their user information in user pools. And we followed this whole approach called we would create a user pool per tenant within Cognito. Like every tenant that we onboard, right? You can tenant is a company, right? So imagine a B2B kind of a scenario. It's a company that's signing up for a SaaS solution. So we create a user pool per tenant, and what we found was, or the way we designed it was, when you create a user pool per tenant, once you're done with your tenant onboarding, imagine that tenant's user logs into the application. So what we had to do there was, we had to go to this table to fetch the user pool, because you have to do that mapping, which user belongs to which user pool. So we had to expose the REST servers and go to a table and extract the user pool information, and then the Angular application would go and try to authenticate with the Cognito user pool, right? So it was a little bit complex, it's a little bit convoluted, and we always wanted to think of, we were looking to replace that, and that's when Farooq came up with this really interesting idea about using a service mesh, and in this case, we are we are using Istio to remove some of those complexity, right? So that we had in what I was describing, the whole user pool per tenant model, and instead hand it off to service mesh like Istio. So that's the challenge we are solving, and we'll deep dive into how we are doing it. But that's essentially in a nutshell. So what we are going to look into today.
So it's not about a replacement solution for the Amazon EKS reference architecture. This is something that's complementary to that solution. Is that fair to say?
Absolutely, yeah. So it is just replacing the way we implemented identity flow a little bit, but the microservices are still deployed in an EKS cluster. We are still following the namespace per tenant model. So this could be a standalone solution too, right? So this can work well with a different architecture as well. But the focus is on the identity aspect and how we are making that better with Istio and right. Service Mesh. Yeah.
And I shared a link in the chat to that previous episode with Ranjith, where we look at, well, actually a deep dive on the EKS reference architecture. Don't click that link right now, but save it and watch it afterwards. I think it's going to be beneficial for you as well. So, okay, so you've set the stage a bit there, Ranjith, on this. So is it time to actually talk about the technical architecture then?
Yes, so basically just want to add a little point there that this architecture and the solution that we're discussing today is based on a blog post which we're working on. It is expected to be out in the next few weeks. It's in the final stages of a review. So the blog post and the related GitHub repo will be available when it's made public. So just wanted to make that reference. So if people are interested, they can look for announcements from our LinkedIn posts or Twitter posts based on whenever it's released.
Yeah, that's great. You can all see our Twitter handles on screen right now. So follow both Farooq and Ranjith for updates on that. And I'm excited for us to be able to do this episode actually before the blog post is out as well. So this is really brand new content we're looking at today. So I see some people are already starting to chat, posting messages and so on. Keep them coming. Good morning to you, good afternoon, good evening, depending on where you are in the world. So this is a show where we actually dive deep into technical content. So I'm excited to look more into the actual architectural bits of this topic. So is it time now then?
Yes, so I'll switch to my presentation. And
there we go.
Yeah, so we'll start with the tenants. As we were discussing earlier, the multi-tenant model. So this basically augments our existing multi-tenant architecture. So we just assume there are two tenants. As you can see on the left side, there's a tenant A and tenant B. The architecture basically uses a network load balancer to pass the traffic through from those tenants to the backend applications. And this network load balancer is associated with an Istio Ingress Gateway, which is part of the Istio Service Mesh. And it's very similar to an Ingress gateway of other forms like Nginx and so on. So it basically associates with network load balancer, spins up an instance of that, and connects external users to the services behind the Ingress gateway. Now, the new idea behind this is what we are going to show you now. So we have two identity providers, one for each tenant. They could be any identity provider per se. They could be a cognitive user pool. They could be social logins, ADFS, any of those identity provider types. What we use to access those is basically a tool of but it's an OIDC proxy. So the specific tool that we use for our use case is OAuth2 Proxy, but it could be any OIDC proxy that is available that can connect to these identity providers. And the really innovative part of connecting to these is an Envoy reverse proxy that we use to segregate traffic from each of the tenants based on the host header that's coming in from the client. So traffic gets routed for authorization and authentication to a specific identity provider based on the host header that is being sent by the client. And once that process is complete, the traffic is forwarded to the specific tenant's deployment of the application in their namespace. As Ranjith discussed, that we're using the same model for tenant isolation, which is Kubernetes namespaces. So as you can see, tenanta.example.com goes to tenant A's namespace, and the services that are deployed in that namespace, and tenant B's traffic goes to their own namespace. So that is a general high-level architecture of the service. We would definitely like to dive deep into a little bit of code.
Yeah. So just something real quick. So because we are showing the architecture, and there are some concepts that is very specific to Istio. So I just want to take a minute, like especially if there are folks that are new to Service Mesh and Istio. So what a service mesh provides is, like, if you have so if you're building modern application architectures that involves a lot of distributed microservices, right? So what happens is there are a lot of things, for example, for traffic management and traffic routing, for things like observability and security, right? So all those concepts becomes really hard when you have a proliferate, a lot of microservices, right? In your architecture, and you need, what developers have done is that, we tend to add code within the microservices itself to handle some of those, like things like rate limiting and traffic management and routing and security and all those aspects. Uh, Instead of that, it's better to hand off the responsibilities to the infrastructure layer instead of embedding that within the microservices code, because it can become really unwieldy, right? At some point. So that's the whole idea of bringing in a service mesh, where you take some of those concepts. In this case, we are doing it with identity, right? So take that and move it to the infrastructure layer so that your microservices don't have to think about it or have to worry about it. So that's why we are using a service mesh, and in this case, we are using Istio. So just to provide a little bit additional context on why we are implementing it, and doing it this way.
Yeah, I think that's a great point there as well. We often come back to that every piece of code that you write, you own it, you have to maintain it, you have to make sure that it actually works and that it's updated and so on. So handing off pieces of that to something like Istio in this case, I think that's a great point to make.
Yeah, and I would like to just tie it back to the 12-factor app principles. So one of the 12-factor app principles is around backing services. So we're just putting these identity providers as backing services here and moving that functionality out of application to the layer that basically is built out of Istio Ingress Gateway, the Envoy proxy, the OIDC proxy, and the identity providers.
And Istio also has other parts that could be used as well, I suppose, with observability and well,
Correct. Yeah. So Istio has a lot of different features which we have not used in this architecture, just to sort of minimize the amount of information that we have. Gunnar, are you able to hear me? I think there's some noise.
Let's see. Right. I hope you can both hear and see.
There's still a little bit of feedback or some kind of a not.
Yeah, now it's gone. So
now it's gone. Yeah.
Perfect. So what we wanted to jump into after this was to show a little bit of configuration of how things are put together in this architecture in terms of the code. So I'll just switch to that and go through some of that information. I'll start with the deployment of the EKS cluster, which is sort of forming the foundation of our architecture. And I wouldn't be covering everything, but feel free to drop in a question if you would like to know more of any of this information. So as part of this cluster that we're deploying, this is just a demo cluster. So we're not deploying large size instances here on EC2. So we're just specifying T3A and T3 types of instances that the cluster should be choosing from. We're using EKS Cuttle as our tool for deploying clusters, which is a very powerful tool, and it can do a lot of pre-configuration while it's deploying the cluster. We're also using the AWS load balancing controller as our mechanism for dynamically deploying load balancers. And also when the code becomes public, you can access it, and you'll see that we're using the spot instances just to make sure that when you use it, when you deploy it, it doesn't cost you a lot in terms of the deployment of EC2 instances. But you could change it if you're taking it to production. You could change it from spot to non-spot instances.
So let's see if my audio works now then.
You're good.
Cool. All right. Quick mic check or reboot. So I'm back. There we go. All right. So yeah, keep going, Farooq.
Yeah. So that's where we start. Once we deploy the cluster, the second piece is the OAuth2 proxy or the OIDC proxy that we're deploying here. The configuration is very simple and basic. A lot of it is default, but there is some information that we put in here from the user pool that we've created. So there's a client ID that the user pool gives you, the client secret. There's a cookie secret that you need to configure, which OAuth2 Proxy uses to seed the cookies that it sends back to the client browser. In the specific configuration, there are a few pieces that we need to ensure that they're correct. So the OIDC issuer URL, the redirect URL. The provider in this case is OIDC. OAuth2 supports various different types of identity mechanisms. So for cognitive user pools, OIDC is the provider type that we should choose. You can choose the scope. We've selected here OpenID. You have to also whitelist domains. So this specific instance of the OAuth2 proxy we're deploying it for tenant A instance, so we have to whitelist that domain. Basically, it's telling OAuth2 Proxy to accept requests from this domain. Rest of it is all default setting. Nothing much to change. Primarily, this information needs to be configured here, and then you're ready to go.
So just to jump in real quick here. So obviously, if you have a multi-tenant environment, you're going to have multiple. In this case, it's a subdomain per tenant, right? So tenant A is the subdomain for example.com. It's the SaaS provider.com, right? So you would have multiple entries right here for a different tenant.
Correct. Yes. So you will basically have an instance of OAuth2 Proxy deployed for each tenant. And each one of those instances will have its own configuration file. So the top few lines for each of those instances will be somewhat different from each other, depending on the user pool assigned to that tenant and the domain that is configured for that tenant. Right. So then we get into the really powerful feature of Istio Service Mesh, which allows us to define what are called external authorizers. And this has been a recent feature added around 1.9 version of Istio Service Mesh. So you can define an external authorization provider within the mesh by using this directive called external providers, give it a name, specify the protocol that it's going to use, and specify the fully qualified service name of the pod which is running the OAuth proxy or any of those OIDC proxies. A couple of other things like which port is running on, timeout, and headers that you want to pass around basically to the upstream to the application pods. So really very simple, a few lines of configuration, and then this tells Istio that this is where I need to send all the traffic that needs to be authorized. Then,
yes, go ahead.
Coming back, yeah. Any questions there?
No, not right now.
Perfect. So coming back to where to something called authorization policy. This is what enforces authorization and authentication. So this authorization policy is applied to the Istio Ingress Gateway, the one that we saw in our high-level architecture diagram over here. So the yellow box. So we're applying a policy here saying that we need to send any traffic that needs authorization to this provider ref proxy that we saw defined previously in our mesh. So this is our authorization provider. So we're going to send all the traffic that requires authorization to that, and then we define in the rules basically the domains for which we need to enforce this policy. So here we're saying tenant A.example.com, tenant B.example.com. You could also define wildcard-based subdomains. So you could say star.example.com as well to cover all the subdomains that are under example.com.
So just to highlight, something that people might encounter, or for example, there is a lot of there are a lot of folks that use things like OPA or service projects like the Open Policy Agent for enabling authorization. So all we have to do is the external provider in this case is OAuth Proxy. So line 15, right? So that's the extension provider that we have defined, the RIF proxy. It's an OAuth proxy. But if you have OPA or Open Policy Agent as part of your application, you could replace this with OPA pretty much, right? And you just have to provide the address for that in the the other file that Farooq
Correct. Yeah. Correct. Yeah. So you have to provide the service endpoint.
The service. Yeah.
Exactly. Yeah. So in this case, we're not exactly sending the traffic directly to the OAuth2 proxy. We're sending it to the Envoy reverse proxy, as we saw in our architecture diagram. So that reverse proxy is going to fan out the traffic based on the tenant host name that is coming in with the request. So that's our single point of redirection where all authorization traffic goes.
And does these different parts in Istio, do they run as separate pods in EKS, or how does that work in the solution?
Yes, so the Istio Ingress Gateway runs as a separate pod in a separate namespace. We want to keep it in a separate namespace. It could run practically anywhere, but we want to keep it in a separate namespace for security reasons, so that only authorized users have access to make any configuration changes and so on.
All right. So what's next then, Farooq?
Yeah. So moving on from the authorization policy, there is another configuration that we need to make on the Istio Ingress Gateway, which essentially defines some of the basic characteristics of the gateway. So we're defining the TLS versions. We're defining where the credentials are. So the certificates for the server, and also we're defining which hosts are allowed to be associated with this Ingress Gateway. So host meaning backend microservices that are running on various pods. So here we're associating anything under two different namespaces. So there's a namespace for tenant A and another namespace for tenant B. So we're associating, we're saying, we're giving it a wildcard. So we're saying all the hosts in that namespace can associate themselves with this gateway. So
yeah, and this is something important. Like if you tie it back to the EKS SaaS reference solution, Gunnar, like we do this whole namespace per tenant model, right? So when we are onboarding a tenant, we create a separate namespace for the tenant. So when we use Istio, like we will have to add that namespace to this host when you're onboarding, right? So it's not manual. Like you can easily integrate this as part of your onboarding pipeline, and all you have to do is like after a namespace is created and provisioned, you'll have to add an entry under host so that the Istio Ingress Gateway knows how where to route that request to, pretty much. So that's the idea.
Yeah, it provides a bit of control as well, so that you only allow namespaces to be associated with the gateway that you actually want to associate. Not just any random namespace coming up and associating itself with gateway. There is a bit of control as well.
Yeah, and you may also have a model where you're not creating a namespace per tenant. You're just basically sharing a single namespace across multiple tenants. In that model, I mean, we call it the pooled model, right? So all you have to do is take that shared namespace and add that under host, and the Ingress Gateway is going to route the request to that namespace. So it's very flexible on how you can do that.
And you could mix it as well to have both types with namespace per tenant, but also have the pooled ones.
Correct. Yeah. So here is just a naming convention that I'm using tenant A and B just to make that differentiation. But it could as well be pooled tenants together in a single namespace.
Yeah.
Next, I would like to jump in a little bit into the Envoy reverse proxy configuration, just to show you how simple it is to configure that. Envoy is generally the proxy of choice on Kubernetes environments. So that's why we chose this proxy. So at a high level, you have to configure two basic parameters, which are one is a listener. So the Envoy proxy has a listener on. You can configure it to listen on any port, but we're configuring it to listen on port 80. And then you define some filters, basically. So one of the filters is access log, and another filter is to look at HTTP traffic that's coming in. So what we're doing is we're looking at the HTTP headers, and we're routing the traffic based on the again on the domain. So this is the host header that's coming in with the request. And we're routing the traffic based on that domain name to a specific cluster. So this cluster is in the parlance of Envoy. That basically is a set of services that are receiving the traffic that is meant for this domain. So we'll just go back to the cluster definition. So for each of these tenants, we've defined the virtual hosts, which are based on the domain. So you have tenant.example.com, tenantb.example.com, and for each one is associated with a backend cluster. And cluster definition looks like this. So primarily it has an address or an endpoint to the service, which is the instance of OAuth2 Proxy in our case, deployed in a specific namespace. So we have a namespace for tenant A and another namespace for tenant B. So we're deploying this and we're putting in the endpoint and the port on which it is listening. So those are the basic settings that you need to do. There is one more setting that's important here, which is to set server header transformation to pass through. So we're telling Envoy Proxy not to modify any headers that are coming from the client and pass them through as is to the backend.
And just to point out, something that's interesting here, to keep in mind is like if you see the OIDC proxy, we are creating it per tenant. So it was a bit deliberate because, right, Farooq? I mean, so the idea was to enforce some level of isolation, so that every tenant, they get their own OIDC proxies, so there's no sharing going on, because it's dealing with cognitive secrets and all that, right? So we didn't want to share a single proxy, so that's why every tenant, if you go back to your diagram, so you can see that right after the Envoy reverse proxy, you have separate OIDC proxy for every tenant, so that we have sufficient isolation there.
Correct. You're absolutely right, Ranjith. So it provides that isolation, and it also provides you isolation during maintenance. So let's say one of your tenants want to change their identity provider from whatever they have currently to somebody else. In that case, the impact is going to be very restricted and limited to that tenant only. It won't be affecting anybody else. So it provides a lot of benefits to have an OIDC proxy per tenant. Unless you are in a pooled model, then in that case there will be a single OIDC proxy. But if it's if the tenants are not pooled, then it's advisable to have a separate OIDC proxy for each tenant. Just one last point here in terms of the configuration. I just wanted to show how we deploy Envoy Proxy. Of course, Envoy can be deployed in a number of ways. But what I would like to point here is that I'm deploying, for example, a couple of replicas of the Envoy Proxy, and I'm deploying it with a rolling update, and I'm setting also minimum ready to be 60 seconds. So the idea behind is when you make changes, you're adding tenants or removing tenants. The current model that we're using here, and of course that's not the core focus of this architecture. We're basically rebuilding the container image of the Envoy proxy, simply changing the configuration file and pushing it back and deploying it again. However, there are open source tools where you can do live update of Envoy proxy with zero downtime. So all those advanced features are possible, and you can build a production ready system with those features.
And that's probably one of the great things about using something like Envoy, that it is tried and tested and it's production ready, and thousands of customers probably are using it already in production today.
Yes, that's right. Yes.
So anything else you want to add here, Farooq, before I want to see it in action?
So this is all from the configuration part. We will next talk a little bit about tenant onboarding. So we'll have a little bit more action there.
Cool. Oh, this is action as well. So and we had my robotic voice as action as well earlier. So just before that, if you just join us, this is Building SaaS on AWS with me, Gunnar. I'm joined by Farooq and Ranjith today, and we're looking at Istio Service Mesh and how that can complement the Amazon EKS reference architecture that we've looked at in a previous episode in terms of SaaS identity and routing. So if you have any questions, if you have any comments, just post them in the chat and we'll try to answer those as well. So let's talk about tenant onboarding then, Farooq.
Yes. So we start tenant onboarding, assuming that we have laid the infrastructure down, including the network load balancer, the Istio namespace, and the Envoy reverse proxy, we start tenant onboarding with creating a user pool for each of the tenants that we are onboarding. So imagining that we have 2 tenants that we want to onboard, it could be 1 or 2 or more, and you can automate all these pieces. What we've done is we've written shell scripts and Python code to automate tenant onboarding, but you could practically use any CI/CD mechanism that you have existing in your environment to onboard tenants. So once we have the user pools ready, we go in and deploy the OIDC proxy service, create the namespace, deploy the service, make those configuration changes to Envoy as well as to the OIDC proxy, so that it's connected to the Envoy as well as the user pool, and that we do for each of those tenants that we deploy. And then we go ahead and deploy the services for each of those tenants, and any configuration that may be required for those services, along with the container images. And also we deploy the Istio Ingress Gateway configuration files that we just saw, so that this namespace is associated with the Ingress Gateway, and the Ingress Gateway knows that it needs to forward traffic for this tenant, and similarly for the second tenant as well. So pretty simple 4 or 5 step process of tenant onboarding, and so I would definitely like to show some the hands-on piece where I can actually run those scripts and show how this onboarding happens.
Yeah, and the goal is to make it as seamless as possible, right? So we want, for any SaaS application, tenant onboarding is very it's crucial, right? So you might have seen all those 5 or 6 files that Farooq was walking us through. So you'll have to you can easily update them, and with zero downtime during onboarding. There's no real manual step where you have to go and add it. So you can easily automate all that during your onboarding process.
And that's also something that we come back to quite often on this show, that onboarding is really key for a good customer experience as well, that it should be easy to start using a SaaS product. So that's a very important point.
Yes, so I would like to again tie it back to the EKS reference architecture. So we have some sample onboarding mechanism in that architecture, which can be refactored and used with this architecture as well. Yeah.
Right. So time for demo then, Farooq, I think.
Yeah, I'm excited. So let me just jump to my demo screen once again. Here. Yep. So I'll just jump into my shell, and so when this code becomes available public, you will see that there's a README file that describes all the steps in detail. So I have followed some of the steps to lay the infrastructure that I already have, and I have deployed 2 tenants, which are tenant A and tenant B. What I'm going to show you is basically deploying a 3rd tenant, which I call, not surprisingly, tenant C. So yeah. So the first step is deploying a user pool, as we saw in our drawing earlier. So I'll just go ahead and do that in my shell. And this is going to ask me, it's going to deploy the pool as well as a sample user. So it's going to ask me to set a password for that user, which I will do. And as you can see, this is tenantc.example.com that we're deploying here. So one piece is done, and the steps are pretty clear here. You create the pool, you create the user, then you're creating the configuration for the OAuth proxy, and then you're updating the authorization policy for Istio Ingress Gateway. So that's one step done. The next step is to do a little bit of reconfiguration on the Istio Service Mesh as well, so that we have the namespaces created and we're getting the Envoy proxy updated. As I mentioned earlier, we just update the image with the new configuration file. As you can see, the only thing we do here is modify the envoy.yaml file and then update it into the image and then push the new container image into our repository. So that is done now. Let's do the next step, which is deploying the tenant microservices. Basically taking our application image and deploying it into the namespace that we created for this new tenant. Just takes another few seconds. And we should be ready there. Yeah, so that basically 3 or 4 step process deploys the tenant.
And the final step right there is where we created the OIDC proxy. Like if you can highlight that for tenant C, towards the end, you can see the OAuth2 proxy being created.
Yeah, exactly. So this is where we're actually deploying the OIDC proxy for tenant C. So we're taking the OAuth2 container image and deploying it in the namespace that we created for this tenant.
Yeah, I mean, we are actually deploying the microservices into tenant C's namespace. That's what you see above, right above the OIDC proxy, right? And then we create the proxy after that.
Yeah.
Mm-hmm.
So yeah, that basically onboards a tenant, and this process can be automated via a let's say an admin portal that can trigger this process, or this could be part of a CI/CD pipeline, which can be triggered when a tenant is onboarded by the administrator. So there are many ways of going about this. The process is very simple. We've done shell scripts here and a couple of Python scripts, but this can be done with any language or platform of choice.
So you mentioned earlier that the GitHub repo isn't publicly available yet, but can you still show what it would look like if anyone would want to use it? Where do they start and so on?
Exactly. So we can. So everything, all the information is here in the README file. So when the repo is made available, it will look something like this. So it'll look something like this here. Right. So it'll be github.com. You can do a git clone, and you will be able to basically get everything that's in that repo. I can. So the code is basically on the left side of this window. It's a pretty flat structure. You will see there's a bunch of YAML files that are created during the onboarding and deployment of the solution. But besides that, all the shell scripts and the Python scripts are you can see them here in the left side of this Cloud9 window.
Yeah, basically, if you follow the README file that Farooq is has on his screen, you should be able to get this up and running in a few minutes.
Very cool.
Yeah.
All right. So now we've done onboarding of a third tenant into our application. Can we also have a look at the request flow when using this solution?
Yeah, absolutely. So I will be showing the request flow in a slide, basically showing how when a client initiates a request, how it flows through, and then I will actually fire up my browser and browse through to one of the tenant URLs, and we can see that flow in the developer console as to what sort of information is exchanged. So let's get to the slide and see how that flow would look like. Here is our tenant who's trying to connect to their application that has been deployed in their namespace. The first step is they send, let's say, a request to tenanta.example.com, which is a request without authorization. It does not contain any authorization information. So that information goes, you will see a GET request. It is going to be blocked by Istio Proxy through its authorization mechanism, and it's going to redirect that into the user pool for authentication. So it redirects that to the hosted UI for Cognito user domain for authorization or authentication. It goes all the way there. It redirects it to a login screen where the user puts in their user ID and password. And once they do this, they will be issued a code, which is the OAuth2 code exchange mechanism. And once they get the code, which you can see in the red there, that code will be passed by the browser back to the Istio Gateway with the callback URL. And that code is now going to be exchanged for a cookie that the OAuth proxy is going to set in the user's browser. And from this point onwards, that cookie will need to be sent with every request for authorization. And as you can see, now the request is going with the cookie. It's going to enter Istio Ingress Gateway, and it is going to authorize that because it knows the cookie. It will let the request go to the backend microservice and be serviced. One point I would like to add here is that the OIDC proxy adds the ID token or the JOT that is received from the user pool. It injects it in the request as it makes it move towards the backend microservice. And that JOT is not exposed to the client side. It's never sent to the browser. It's just injected. Whenever a request comes in for authorization, it injects that JOT in there, and that JOT is sent to the microservice in case the microservice needs to inspect the JOT, crack open, and see if it needs any information from there.
And just a note on the cookie, Farooq. So so there is a session expiry time. So like after the first request, the subsequent request doesn't have to go through the whole authentication process as long as the cookie is still alive, right?
Correct. Yes.
Yeah.
So you can set a validity time for the cookie or expiry time on the cookie, which should match on the session expiry that is set on your identity pool. They should both be in sync. Otherwise, your users will start seeing weird errors.
Yeah.
Right. So yeah, that basically is the flow. And yeah, we would actually like to jump into a browser and show.
Yeah.
Maybe before you do, so there's I think I just thought of something. So I mean, what we're saying is you could offload the the security checks, right? So let's say in this case, the JOT token is going to flow through this all the way to the backend microservices. So it's if you want to do another set of validation without within your microservices, you're free to do that. You can do that if you want like end-to-end sort of zero trust kind of a scenario, right? But if you don't have that and you just want to offload that to the infrastructure layer, like what Farooq was showing, so this is a great way to do that. But the JOT token is still going to be passed all the way to the microservice services, like that are sitting inside the tenant namespaces. So you have the option of looking into the JOT token, and if you want to do an additional set of validation with that JOT token, going back to the cognitive user pool, you can do that.
Thanks for adding that, Ranjith.
Yeah, so just wanted to,
Absolutely, yeah.
Right, Farooq. So let's see a request in the browser then.
Yeah, so I will just fire up my browser. So as you can see, I've already opened the developer console. I have the URL in place. So URL I'm using is tenant.a.example.com, and I have also a path-based routing. I'm using the sample book info application that the Istio distribution provides. Relatively simple, straightforward application, single page. The only reason I use it here is that it's really not relevant to the architecture. You could deploy any application of any level of complexity behind this architecture, and it will work. So let me just click on the link. So you can see how the request is flowing. So I'm doing a get to tenant.a.example.com/bookinfo. It is getting redirected to my hosted UI for Cognito user pool, which basically is going to show me this login screen. it is it is passed through because my OAuth proxy has the client secret, and it is authorized to make this this call, the redirection call. So I'm being asked for my user ID and password. So I will use my user ID. And once I log in, you can see that I have landed onto the application. And again, we can look at the flow. So this is going to redirect me to the actual application, or the callback URL, along with the code, which can be seen here in the response header. And once that code is sent, there is a cookie that OAuth proxy sends back to my browser, and that cookie is set now, and I can start sending requests to the backend application. And with every request, you will see that this cookie is being sent. So every single request here is going to have that cookie, and that will authorize my request automatically as long as the cookie is valid. And similarly, I can browse to another tenant. So this is now tenant B. I can do the same thing. It'll take me to a different user pool. Here I can use I can log in with a user from that user pool. And as you can see in the URL as well, so the redirect URL is for tenant B. So it's taking me to a different user pool now. And yeah, so this is the second one. And also the third one that we just deployed, we can go and do the same thing.
Yeah, I was going to say if you can show the third one, because that's what the new tenant that we onboarded.
Exactly. Yeah, exactly. So yeah, so doing exactly that. So this takes us to the third tenant's environment.
Very cool. All right.
Yeah. So nowhere in this flow, if we go back to what we were, how we started this whole conversation, right? The EKS SaaS reference architecture, what it does is from the browser, it would have to go do an API call, fetch the user pool information from this table, and then go to the cognitive user pool, to authenticate the tenant and the tenant user. We don't have to do all of those. All of that complexity is gone. Instead, we are just relying on Istio here and offloading that work to Istio.
Right. I just wanted to add one more point here. So the OIDC proxy, particularly OAuth2 Proxy, it keeps session information in memory, but you can also configure a Redis cache along with that. So for persistence and for longer term, keeping of that data, or in case you're going beyond a single instance of OIDC proxy for a specific tenant. So that'll give you an opportunity to have a centralized location for session information.
So we're approaching top of the hour, so getting time to wrap this up. I had a question around noisy neighbor. We often talk about that in terms of SaaS solutions. Is there anything to think about there? Could that be something you have to worry about in this type of solution?
Well, I mean, so it goes back to one of the earlier points that we were making, right? So for identity, that's exactly why we have a separate OIDC proxy for every single tenant. So the first time we approached this there was a single proxy that would accept request, and then it would go to the user pool. But we felt that you don't want to have something like that, especially noisy neighbor scenarios. And what if that proxy goes down for whatever reason? It's a single point of failure, and so we didn't like that model. And so that's when Farooq came up with a separate OIDC proxy for each tenant. So that way it's easier to manage, easier to upgrade. And if you want one tenant to go use a different provider, you can do that. There's a lot of flexibility in that model. So that's one area. And I don't know, Farooq, are there any other bits that we want
Yes.
to highlight?
So another area to look at, maybe from a noisy neighbor perspective, would be to deploy a tenant that demands more on a different managed node cluster. So that is another aspect of it. So if there's a need for doing a special type of processing, or certain tenants require different types of underlying hardware, you could deploy them on a separate node group within the same cluster. So all those customizations at the Kubernetes level are possible. So you can have your taints and tolerances. All those features are completely available to you in order to segregate between your tenants.
Great. All right. So time to wrap up then, I guess. An hour flies by when we're talking SaaS, apparently. So Farooq, can you walk us through what we covered in this episode of Building SaaS on AWS?
Right. So we looked at the two challenges that we talked about at the beginning of the session. One of them is around identity and being able to connect to various types of identity providers. And the second is the ability to do routing. And doing both of those without a lot of heavy lifting within the application. So taking those large pieces of interaction and pushing them to the infrastructure layer is basically the crux of this new architecture suggestion.
Ranjith, anything you want to add?
No, I think Farooq summed it up pretty well. We are actually working on, sort of another effort where we want to bring in App Mesh, which is the AWS Service Mesh, into the mix as well. So that is something that we are looking into, and then we want to do better automation around this whole thing. Right now, it's standalone. It's done using scripts, like Farooq was showing, but so we want to do it like the EK SaaS reference architecture, where the onboarding is automated and everything is just at the click of a button. So we want to get there. So that's something that we are working on right now, and so hopefully we'll have that sometime, by this year. We should have that out. But otherwise, I think that was pretty much it.
Yeah, that's great. All right, and Farooq, as you mentioned early on in the episode, the blog post and the GitHub repo will be available soon, in the next few weeks, I think you said.
Yeah, that's right. So stay tuned.
Yeah, stay tuned. Follow us all on Twitter. You'll get notified as soon as it's up, for sure. So with that, Ranjith, Farooq, I want to thank you both for joining us. I want to thank everyone for watching, the questions in the chat. Thanks to Bill handling the questions in the chat as well. So thank you for that. And I hope everyone enjoyed this episode of Building SaaS on AWS. And once more, thank you all. And I hope to see you again in 2 weeks.
Yeah, thanks for having us on your show.
Thank you.
Bye-bye.
Bye.
All right. Bye.